This tutorial is going to show you how to calibrate a camera, that is, determine its position and orientation using surveyed targets. We're performing this calibration in order to carry out a later 3D analysis with these cameras, and hence we need to do this for two cameras, both of which are seeing the same view. The cameras must not be moved or adjusted prior to recording the motion being analysed later, and to do the calibration we need 6 surveyed points which can be seen by both cameras in one frame. The first step is to bring in the two camera views and set the camera parameters of focal length and pixel size. Now we need to bring into each view the survey which has previously been performed of the reference points. This needs to be an ASCII file with a TRG suffix in the format shown, where the length units are shown in the top line, and the following lines consist of the reference point name and the XYZ location of that point, using white space as the delimiter. Alternatively, you can use the Edit Reference Point option and enter the points manually in the program. To bring the file in, highlight each image in turn, and under the camera menu import the reference points, import from file, and bring in the ASCII file which will have the TRG suffix. Make sure that the units are correct, and as you bring in the survey the points will be added to the points list. On the camera menu there is an Edit Reference Point function to allow you to review and edit the import file, and also this file can be exported to the necessary TRG file. Now attach each target to the respective point in the image in both views. Turn off any point that is not in the survey. Once this is done, highlight all the points in one of the test contents list and use the View menu, Show Window option to get a zoom view of the targets and adjust them. If you are using quadrant targets, right-click to set them all to quadrant algorithms, at which time they will click onto the quadrant center lines if they're not right on. If they click anywhere else, you may need to hold down the Alt key to move them. Now for each image choose the camera menu, camera orientation and static camera orientation. First turn off the E point, which we are not using, Then set the Adjust Focal Length option on and click Go. You will then be presented with the camera orientation, that is, position and orientation angles, and the revised focal length for the camera. The residuals in the calibration will give an indication of the level of accuracy of the calibration. At this point, the camera calibration is complete. The camera positions and orientation have been calculated in the coordinate system that was used in creating the survey. Now save the session, which will save the calibration. Now we will start a 3D tracking session in which we will use the same two cameras in the same position in which we have just calibrated them. Once you have the two views, on the camera menu, go to the Import Camera Properties option and import for each camera from the calibration archive you've just saved. Both camera calibrations are in the one archive, but you must check to select the correct camera, left or right, for each image. As you can see, the adjusted camera focal length and position have been brought in with the calibration. Now we can advance the image sequence to where we can see the item we want to track in both images. Add a point to both images and track the point in both images in the first frame. Now start tracking forward and the 3D position will be generated. There is a back projection feature which is very useful. Here a point has been unregistered in one image, and the back projection line now showing is the line on which the program expects the point, tracked in one image, to fall in the other image. This can help in the location of a feature you're trying to track, and also gives a good idea of the accuracy of the 3D tracking.